So good morning all of you. Myself Indrajit Kumar today presenting on the strata control in depillaring. Now first of all we will look at the what is ground control. It is a collective term given to the techniques that are used to regulate the collapse and failure of mine openings. It is also the science that studies the behavior of the transition from one state of equilibrium to another. It provides the basis for the design of the support systems and prevent the chances of the failure of the roof, floor, ribs and both safely and economically. Now we will look at what is the need of instrumentation and monitoring. Generally, it is used to record the natural variations in geotechnical parameters before the starting of a project and after the completion of the project to ensure the safety during construction and operation by giving warning for development of threshold values or any impending danger. It is used to check the validity of the assumptions, conceptual models, and the values of the properties used in design calculations to control the implementation of ground treatment and remedial works. Now we will look at the rock stresses that are present in a rock. Generally, two types of rock stresses. First is the in situ stresses that exist in the rock prior to any disturbances. It is the natural form of stress that is present in the rock. And the second one is the induced stresses, which are created after an artificial disturbance like development, excavation, pumping, injection. So the redistribution of the stress occurs. This is the induced stress. The basic parameters that need to be monitored during depillaring in advance of the phase are the roof fall parameters, side fall parameters, go behavior parameters. In roof fall, we need to look at the convergence, bed separation, sagging and deflection, load on supports. In side fall parameters, dilation of the side closure, pillar strain, stress concentration, and side crushing. Go behavior parameters are the convergence or roof and floor closure, caving trend, go filling or cushioning. Now we will look at them first. One First is the mining induced stress. In case of depillaring operation, the redistribution of stress over remnant pillars, rib structures are monitored with the help of stress meters. Stress meters are very important. The trend and the pattern of the redistribution of the stress in the rock mass around an excavation are monitored in terms of the change in the stress levels. Generally, a number of stress levels are fixed to pick up the variations of the mining induced stress with phase advance in a depillaring panel. Second one is the convergence or the relative displacement of the two points of the boundary of excavation and is probably the most frequently taken underground measurements. During depillaring, convergence is measured continuously to get information on the bed separation. This convergence monitoring may improve the safety of the workplace. Third one is the load on safety supports. The stability evaluation of a freshly exposed roof over a gallery is generally done with the observation of load on supports. Load cells are generally placed below the applied supports like props, chocks to measure load encountered during different stages. Now the bed separation. A borehole extensometer with multi-anchor facility is used to locate the parting horizons. This instrument is generally fitted in an upward hole drill from the working horizons. It provides valuable information till roof is intact and in the case of development of core. Now we will look at the strata control instruments that are frequently used instruments for strata control investigations. First one is the load cells, convergence indicator, instrumented boards, stress meter, strain bars, borehole extensometer. Load cell, borehole extensometer, convergence indicator, readout unit. These are the pictorial view of these instruments that generally used in strata control. Now I have a case study of GTK 5A incline in SCCL, and the support design parameters are as given. The maximum depth of cover is 180 meter, thickness of the seam is 2.1 meter, pillar size is 32 into 30 meters center to center distance, width and height of the gallery is 4 meter and 2.1 meter respectively. Width of the split and slice are 4 meter rib width against the goof. Weighted average of in situ stress ratio K is 3.92 divided by 2.06, that is the ratio of horizontal stress by vertical stress is 1.21. Now we will look at the support design for depillaring face at GDK 5A incline. In the GDK 5A incline, conventional split and slice method of extraction was adopted. During depillaring, they were using 3 sets of bolts in a row at spacing of 1.2 meter in split galleries and 2 wooden props in spacing of 1.2 meter in each slice. So in each split they were using 3 bolts of 1.2 meter, and in each slice they were using wooden props, 2 wooden props at spacing of 1.2 meter. In addition to that, in the center of the slice junction, a wooden cog is erected, and at the gouge edges 3 sets of wooden cogs are erected. And with this support system, applied support load density can be estimated using the equations derived. This is the support pattern for depillaring face. You can clearly see that in the center there is a chalk support, and in the gouge edges 3 sets of wooden cogs are placed, and in the gallery 1.2 meter grouted bolts are placed, and in the slice wooden props are mm, given at 1.2 meter interval. Now in the conclusion, we have the derived equation for the support load density at the junction within the slice, split gallery, gouge edges, and these are the formula where gamma is the weighted average rock density, H is the mining depth, K is the in situ stress ratios, W is the width of the split or slice, R is the weighted average RMR. And so these are the references. Thank you.